In many different sports, we want to hit or throw something the furthest distance we can. This can be affected by a number of different things, which are the initial angle of the throw, the initial velocity of the throw, and the force of gravity acting on the thing we throw.
What about air resistance?
Well, Sammy, air resistance would have a massive effect. However, we are going to assume that it's negligible.
What about launch height?
Well, launch height would also have an effect on how far the ball goes. However, we are going to assume the ball is launched from ground level.
What about weight?
Well, since there's no air resistance, we're assuming that the weight has no effect. For example, in this video of Neil Armstrong dropping a hammer and a feather on the moon.
For our Falcon, and I'll drop the two of them here, and hopefully they'll hit the ground at the same time.
They have the same downwards acceleration.
This diagram shows the flight path of the ball as it travels through the air. Alpha is the initial launch angle, and V, the hypotenuse of this triangle, represents initial launch velocity. V sin alpha is the upward component of the velocity going vertically upwards, and V cos alpha is the horizontal component of velocity travelling sideways, which will create a distance of the throw. We can work out the time it takes to reach this point, the highest vertical point on the graph of the throw, by using this equation. The velocity of the upward component divided by the rate of deceleration on Earth caused by the gravity, 9.81 meters per second squared. And then we are going to assume that both parts of
Now we
this
have
flight,
worked out the horizontal speed
rise and the fall,
the
time of flight,
equal
length and time.
We can use these
So
two
we're
values
just going
to
to
work
times
out
this
total
equation
distance.
to reach
This
the
has been
maximum
greatly
velocity
simplified
to
by
reach this formula. 2 velocity squared times by the cos of alpha times sin of alpha divided by the rate of deceleration of gravity, 9.81 meters per second squared. Luckily, I drew this very helpful graph. This is a graph of sine x times cos x.
As we can see here, the angle of 45 degrees creates a very long flight path as it's the optimum angle. An angle greater than 45 degrees produces a much shorter flight path, and an angle much less also produces a much shorter flight
Therefore,
path.
value of alpha, which will give the greatest value for cos alpha sin alpha, is 40.